We hear about being data-driven all the time, but like, what does that even actually mean,
Yeah.
So that's what today's deep dive is really going to try to unpack. We're looking
Yeah.
at a chapter from this math textbook, and it's surprising how relevant it is to just understanding like everyday life.
Yeah, I mean, data is everywhere,
Yeah.
but it's really how you handle it that takes it from just being numbers on a page to actual insights.
Okay, so the textbook starts with these like really relatable examples of raw data. You've got sports scores, a student's grades, even just like a list of what everyone in your book club has read, stuff we see all the time.
Absolutely. And, in that raw form, data can be a lot.
Total.
Like if you're trying to figure out, for example, how a whole school feels about their favorite subject, and you just have this big jumbled list of answers.
Right, yeah, just like history, math, science.
Exactly. It's not very useful, is it?
No. So that's where the textbook introduces this idea of frequency. And it sounds kind of basic, but it's huge.
It is. It's a game changer. Because when you organize data by how often something appears, you go from just a list to actually seeing a pattern.
Yeah.
So the textbook gives this example with the favorite school subjects. But instead of that messy list you were talking about, you see that, say, history came up 12 times, math was 18, and so on. You immediately get a sense of what people prefer overall.
Yeah, it's like instead of just knowing someone got good grades, now you see they consistently get like high 90s. And that tells a whole different story.
Totally. And this goes way beyond school stuff. Imagine applying that same concept to, like, I don't know, customer preferences for coffee flavors or something.
Oh,
You suddenly understand what's popular, what's not, maybe even start to predict what people might want to see next. That's the power of organized data.
it's like finding the signal in all the noise,
Yeah.
right? But we're not just about tables and numbers here, are we? The textbook gets into visuals, too.
Yeah. Data visualization is huge for making those patterns even more clear, and our brains just naturally gravitate towards visuals. So the textbook starts with some classics, or pictographs and bar graphs.
Oh, yeah. They always seem so basic, but there's something so satisfying about seeing data represented that way.
Right.
Like the textbook uses a bar graph to track how many books a student read each month. And you can instantly tell when they have their best reading month.
Exactly. It just clicks, But there's this other visual the textbook talks about that I find super interesting.
Mhm.
Histograms.
Histograms. Okay, so are we still talking about bars here? How are those different?
It's all in how the data is grouped. So
Yeah.
remember those frequency distribution tables we talked about?
Right, yeah.
Histograms take that idea and make it visual, like say
Right.
you're looking at test scores. Instead of a bar for every single individual score, a histogram puts them into ranges.
Okay, so instead of seeing that one student got a 78 and another got an 82, you see how many students scored overall in that 70 to 80 range.
Yeah. So each bar represents a range of scores.
Yeah.
And the height of the bar shows you how many scores fell within that range.
Yeah.
Like the textbook uses an example with student heights. You see right away that most students are within a certain height range. It gives you this quick snapshot of the data's distribution.
Okay, I'm seeing how powerful this is. We've gone from this jumbled mess of numbers to these organized tables, to these visual representations. Like each step we take reveals more of the story that's hidden in the data.
And believe me, that story gets even more interesting. But before we get ahead of ourselves, we should talk about another visual that's really good at showing proportions, the pie chart.
Oh, the pie chart. Love them or hate them, they're everywhere.
They are. And there's a reason. They're super effective at visually showing you parts of a whole. Like you just see it instantly. If half the pie chart is one color, boom, that's 50% of the data.
Like slicing up a pizza,
Yes.
you instantly know who got the biggest slice. The textbook uses this example of how someone spends their day, work, sleep, all that. And you see right away what takes up the biggest chunk of their time.
Exactly. And as simple as pie charts seem, they can communicate pretty complex information really quickly and clearly, especially when you're dealing with proportions and percentages. Each slice of that pie tells a story.
So we've got these visual tools, we're starting to see patterns, but like life isn't always neat charts and graphs, is it? What about chance and uncertainty? Where does that fit in?
You're right. Things aren't always so predictable. And that's where the textbook takes, honestly, a surprisingly profound turn. It gets into probability.
Probability. Okay, that word kind of takes me back to math class. And maybe not in a good way, but I have a feeling this textbook isn't about to throw us into like crazy formula land.
Not at all. It starts with something super relatable.
Yeah.
Just the simple act of tossing a coin, heads or tails, that classic 50-50 chance.
Yeah, we've all flipped a coin to make a decision at some point, I'm sure. But how does that tie into this bigger idea of probability?
Well, it all comes down to understanding what we call equally likely outcomes. So when you flip that coin, you've got no control over whether it lands on heads or tails, right?
Right.
Each outcome, heads or tails, has an equal chance of happening. And that's like a fundamental concept in probability.
So it's not just about coins then?
Nope, not at all. The textbook actually, it extends this to dice rolls too. Each side of the die, it's got a 1 in 6 chance of landing face up.
Right. Okay.
So those are all equally likely outcomes as well.
Okay, I see how those are like simple examples, but how does this probability thing actually play out in more complicated scenarios? Like, can it really help us make decisions when we're not sure what's going to happen?
Absolutely. Think about what we were saying earlier about feeling overwhelmed by data. Probability gives us a way to cut through that, to make smarter choices, even when we don't have all the answers.
Can you give me an example?
Sure, let's say you're running a business, right?
Hmm.
And you're trying to decide whether or not to invest in, I don't know, a new product line.
Okay, yeah.
You've got market research, sales projections, all that data.
Mm-hmm.
But there's always a chance it might not be a hit.
Right, no guarantees in business, right?
Exactly. But understanding probability can help you figure out how likely it is to succeed. You can look at past data for similar products, analyze market trends, and use all that to make a better decision about whether it's worth the risk.
So it's kind of like, instead of just crossing your fingers and hoping for the best, you're making a calculated decision based on, like you said, the probability of different things happening.
Exactly. And this applies to so many areas of life. I mean, think about it. Personal finance, health decisions, everything.
Yeah.
It's about realizing that uncertainty is always going to be there, but we don't have to be afraid of it.
Right.
Probability gives us a way to deal with all those what-ifs.
Wow, I never really thought of it like that before. It's like it takes us from being overwhelmed by uncertainty to having a tool to actually work with it. But let's bring it back down to earth for a sec. The textbook mentioned things like election polls and weather forecasting.
Yeah.
How does all this connect to that?
See, that's where it gets really cool. Remember those exit polls we were talking about earlier?
Yeah.
Perfect example of probability in action. So by asking just a small, carefully selected group of voters, analysts can use probability to actually predict what the overall election results are going to be.
So instead of asking every single person who they voted for, they just use this smaller group to kind of get a sense of the big picture.
Precisely. It's all about using a representative sample and statistical analysis to figure out what's going on with the whole population.
That makes sense. And what about the weather? How does probability work with, those sometimes questionable forecasts that we see?
Well, meteorologists actually use a ton of data to make their predictions. Historical weather data, complex algorithms, and, yep, you guessed it, probability.
Oh, wow.
They're not just looking out the window and taking a guess. They're analyzing things like temperature, wind speed, precipitation, all to figure out how likely different weather events are.
So when they say there's like a 70% chance of rain, they're not just pulling that number out of thin air.
Not at all. It means that based on what they've seen in the past and the current conditions, similar situations have led to rain 70% of the time.
Wow, okay, you're making me look at my weather app in a whole new light.
Yeah.
It's like this little window into the world of probability, trying to make sense of the chaos of the atmosphere. But before we get too carried away with, rain clouds and elections, I'm curious about something. We've talked about how to organize data, how to visualize it, even use it to calculate probabilities. But what about its limitations? Are there times when data can be, misleading or even misused?
Ooh, that's a really important point and something to be super aware of, especially as we move into this world that's more and more data-driven.
Yeah.
Data itself, the numbers and stuff, they're neutral. They're just information. But it's how it's collected, analyzed, and presented that can really change how we see it.
So it's not enough to just see a chart or a statistic and just be like, okay, that's that, and take it at face value.
Right. We have to think critically about it. Like, where'd that data even come from? Who collected it? What were they trying to prove or show? There's a human side to all this data stuff that we can't forget about.
Can you give me an example of how data could be misleading? I mean, it's just numbers, right?
Well, even something as simple as a graph, right? Think about it. How are the axes labeled? What colors did they use? Even just the title of the graph, those things can change how people understand the information. You can have a graph that's technically accurate but still tells the wrong story, especially if someone's trying to make a specific point.
So it's like even if the numbers themselves are legit, the way they're shown can completely change the message.
Exactly. And then there's the whole issue of bias when you're actually collecting the data in the first place. Like if a survey is designed badly,
Yeah.
or if it only asks certain types of people, the results aren't going to reflect reality.
Yeah, that makes sense. Like if you only ask people in, I don't know, one neighborhood about their favorite ice cream, you're not going to know what the whole city actually prefers.
Exactly. So as we become more data literate, it's more important than ever to use that critical thinking. Ask questions, be on the lookout for potential bias. Don't be afraid to dig a little deeper.
So it's not just about knowing the technical stuff about data, it's about being a little skeptical, looking at it with a critical eye.
Absolutely. Data can be incredibly powerful, but like any powerful tool, it can be misused. The more we know about those potential traps, the better we can navigate this data-filled world. You know what I mean?
It's like we're not just learning a new language, we're learning how to read between the lines of that language.
That's a great way to put it. Data literacy is about so much more than just crunching numbers. It's about developing this, like, lens, a way to really see the information that's all around us.
This has been, honestly, eye-opening. We started with these, almost basic ideas from a math textbook. Organizing data, making graphs and charts. Then we got into the, I don't know, almost philosophical stuff with probability. And now we're talking about the real-world impact of data for good and for, well, maybe not so good.
It's all connected, Data handling might sound kind of technical, but really it's about understanding patterns, making sense of uncertainty, and in the end, making better decisions.
For me, I think the biggest takeaway is that this whole data literacy thing, it's not like you just get it and you're done. There's always more to learn, more to ask about, more to explore.
100%. And the more we embrace that journey, the better equipped we'll be to handle everything this data-driven world throws at us.
So to everyone listening out there, next time you see some statistic, a graph, or just someone making a claim based on data, don't just take their word for it. Ask questions, think about it, see what you find. You might be surprised.
And remember, data is not just for the experts. It's for everyone. The more we understand it, the more power we have to make smart choices in all parts of our lives.
And that is a wrap on today's deep dive into the fascinating world of data handling. We hope this episode has, I don't know, maybe piqued your interest a little bit and given you some new ways to make sense of all the data out there. Until next time, keep exploring, keep asking questions, and keep diving deep.